This is my presentation for the critical thinking of week 8 for CSU Global Chem 122, How Does a Nuclear Bomb Work? To begin, we'll discuss the history of nuclear warfare. So beginning in 1945, nuclear warfare was introduced when the first nuclear bomb hit Hiroshima in Japan. This horrific event caused thousands of people to perish from impact as well as radiation poisoning over the next year. We'll talk a little bit more about that further in the slides. The first attack opened up a very dangerous but also controversial type of weaponry to our world, and most importantly, its ability to wipe out mankind. So the components. Let's discuss what is needed to create the necessary chain reaction within a nuclear bomb. So you have fuel, temperature, pressure, confinement, and ignition. All of these are uniquely required in order to create the necessary chain reaction. Fuel and temperature. So fuel. Need a fuel with atomic nuclei, generally a hydrogen isotope, which are commonly used in fusion reactions. Temperature. A high temperature in particular, one of at least tens of millions of degrees of Celsius, is needed to overcome the electrostatic repulsion between the atomic nuclei and to enable them to come close enough to undergo fusion. So you need very high temperatures and a fuel. Next up is pressure. Pressure, and particularly high pressure, generally several atmospheres or more, is required to confine the fuel and maintain the high temperature required for fusion. Confinement is next, and we require a way to confine the fuel and keep it in a small volume for a long time to allow for a significant amount of fusion to occur. Thinking about confinement, we can think about what's going on inside the bomb itself and how it's made in terms of the vessel that it's put in. We'll get a little bit more into that as well. Looking at the picture to your right, it does help kind of explain what's going on inside versus outside. Next up is ignition. So finally, we need a source of energy to initiate the fusion reaction and provide the necessary energy to overcome the electrostatic repulsion and bring the atomic nuclei close enough together to undergo fusion. So I have a picture of a match there posted on the left. Typically what we think of with ignition. So how does it work? Nuclear fission. The nucleus of an atom is split into two or more smaller nuclei, releasing a large amount of energy in the process. The nuclear fission reaction is the basis for the atomic bomb, and it involves the following steps. So again, nuclear fission is the basis for the atomic bomb, so we can think of that in terms of the original atomic bomb in Hiroshima. Nuclear chemistry. So we'll start with critical mass. A sufficient amount of material, such as enriched uranium-235 or plutonium-239. I believe uranium-235 was talked about in the video provided, which was very helpful, and that's pictured below, must be assembled in one place to reach a critical mass. The critical mass is the minimum amount of material required for a sustained chain reaction to occur. Next, neutron triggering. This is super important. The critical mass is surrounded by a shell of neutron-reflecting material. When a neutron is introduced into the assembly, it triggers the fission reaction by being absorbed by one of the fissile nuclei. Next, the chain reaction. The absorbed neutron causes the nucleus to become unstable, releasing additional neutrons and a large amount of energy in the form of heat and radiation. These released neutrons go on to cause other fissile nuclei to split, releasing more energy and additional neutrons in a self-sustaining chain reaction. Explosion. The rapid release of energy produces a massive explosion, as well as a large amount of radiation in the form of gamma rays and other high-energy particles. This is the cloud-like explosion observed. So when we observe what goes on with an atomic bomb, you see a giant cloud, and that's the explosion part. Prior to this, like I said, there's radiation in the form of gamma rays that happens with the explosion, and so that's what people after Hiroshima were experiencing a year later. They got sick, and this was from radiation poisoning that lasted up to a year after the tragic event. And here are my sources. Thanks so much.